Howdy, this is a lecture set on the regulatory for GIS and petroleum. GIS has a huge potential to help the petroleum industry, specifically on the regulatory aspects of what we have to submit for either permitting a well or reporting information. To give you a good example, here is a permit that we can see here that is being submitted in Colorado on a location to be drilled, in this application to be drilled in this scenario. Looking at the documents that were all submitted for the process to try to drill this well, they give several bits of information, and a lot of this has even information on how to get to the site. In case of emergency response, they will pull this information and be able to do this. So existing roads, road information, all this needs to be provided, and telling them about the location, the water supply, the construction materials that are going to be used, the methods of drilling that's going to take place, where the fluids are coming from and where they're being disposed and how they're going to be disposed. A lot of this information is necessary for our application to drill, and it can be represented in this text file, but it also can be represented in plats and maps. Here we see an actual plat for the drilling and key things showing where it's at and where in this section, and the ties to these corners, or how far is it to the nearest well at that location. Although this is a surveying plat that might be done in AutoCAD, the AutoCAD portion is part of a GIS, and the information of this boundary and these locations and these section lines could be pulled from the GIS database into the CAD information, and ultimately is the same information that we get from a subsurface or the engineering from drilling that can be shared across those whole areas. You know, things such as topology maps that need to be made. This is obviously drawn in some fashion in this example, maybe by manual cartography. Looks like they even could have drawn it in Office or Paint or Publisher, where you could do a better job of providing this information and these routes to get somewhere from that scenario. Other things such as looking at radiuses. This looks to be more of a GIS type solution, but this might not have been done in a GIS type software. It could be done in maybe subsurface type software, and they again did manual drafting from this application. We get into construction drawings showing where we're going to put waters or ponds, tanks, pipelines coming in, roads, existing well pad, new well pads, cross sections. Again, a lot of this information might be very CAD oriented, but if drawn correctly, we can use FME and pull a lot of this information up to our GIS, because we do need these ties to the very long across to wells and different information, and that can be housed in our GIS. Here's a typical drilling site layout. Again, this is a typical that you could actually port over and have this document assigned to that location and have that cross sections easily done in GIS. Again, disturbance, where you're disturbing the earth. And when you get over to the drilling plans and we look at the drilling plans with the depths, a lot of this is coming from our drilling software such as EDM Compass and some of those things, but a lot of the surface, the take points, things of that nature come off the survey plat, which again can be built inside the GIS, or at least tied in through the GIS from that standpoint. All the casing information, all this documentation, where does this reside? Is this captured in attributes that can be assigned to these wells? That is very valuable and helpful. Even schematics of, say, the Christmas tree and the wellhead, having those linked to where I could just click on a link inside of GIS and see how that was built or put together or these drilling reports is very useful. And again, here's another look at very similar, redrawn, recaptured. It was drawn in one system, then redrawn in another system, versus sharing the information across, for multiple people. And then we have the as drilled report, any collision report. Where are they getting all this information? How is this being databased? Did they draw it in the as drilled? Was it put into there so that we have it in a 3D sense? Well, probably not. So that's something that where we could use the GIS from that element. So, looking at, here's another example. Here's one I had to submit when we have the spacing, and knowing where they're located at becomes a big thing. Now the ties and the distances, in knowing where you are at to the boundaries, this first take points and last take points for the spacing and the setbacks become very important, because if you don't get that ideally correct, you could lose a frac station, where each frac station, economically could make or break some of these wells. These numbers here that are put into the permit, carried over to the drilling, carried over to the subsurface. Everyone is not just taking this plat and reproducing it in their system. Imagine that if this data that is created is carried over from the GIS to the plat, from the plat to the GIS to the subsurface software to the drilling software, it becomes very advantageous to everyone that is using that product. In an example of that, of where I can show you where I had built in my GIS a ability to use all of those different products in the GIS, going all the way back to, say, my avoidance GIS. And here you can see where I've made an avoidance area where we want to try to avoid. Here I have a area that was not pulled into a unit, so we have to avoid that. We have angle points specifically. I calculated what those angle points are that need to go into EDM Compass. Then we have avoidance points that we have here in terminus of the well, so they know this in the steering aspect. If we have any offsets or other wells that we need to avoid, that is all being supported from the GIS. And again, even in the construction side, all my construction drawings are being pulled into a CAD system, but they're being replicated back and forth into the GIS. And so what happens in that scenario, where we have where the actual well is going to be, which way we're going to spud, the existing pad that's out there, we can have an idea of what that is, and it's shared not only to myself but others who might be bringing in utilities or pipelines or other information. It's not just going after a paper map, it's connected from those portions. If you're doing a drilling unit plat where you have to submit something, all those ties again are very important. As-builts, the way that the pad is being built after you've done it, getting that back into the GIS. And then as-drills, looking at the actual locations where your frac stations are. This could be very beneficial, especially if you had prorated, or if you're trying to avoid some areas that's not pulled, you can fully show where that's at through those examples. Now, when you look at using a GIS to try to submit things specifically, you're going to be filling out a form. The regulatory agency, for drilling permits and how to go in and fill out that, each government or state has different aspects of what they require. But for the most part, let's take a look at this Railroad Commission. They look at taking the information that's on the plat and typing it in, and it's sometimes subject to errors and problems. We actually take and we can make a form builder that actually fills in the form for us for the GIS. I have an FME job that actually pulls the data that's from the GIS and populates it to what they have to turn in the form. Because as they say in this scenario, when you go to this website and you type all these things into this website here, and you hit set or send or save, what is actually being done. This is on your desktop. You can actually have an FME job that pulls these sets of informations that are coming off your plat that are in the database, automatically filling in the information inside this table, and it will send it for you. And then you can open up the table and see what it looks like. And then what you do is, instead of somebody's taking and reading a plat and then filling in every pieces of this information is not typed more than one time. I can read this plat with the FME, populate the GIS, and from here populate from the GIS to the permit. This saves a lot of times all of the information that needs to be known and done. All right, all your offsets, any exceptions, any lease ties, survey ties to the north, to the south, all this information can be put into the GIS. I've made a GIS, you'll see, of those points that I did for my Elf Energy in our exercise. Later I'm going to show you how to pull an FME to populate those from the CAD drawing directly. And even landowners, who owns this, all this other information can be put into there very simply. But I do want to go back, and before I conclude right here, and just talk about quickly the concept of what is the spacing, and that becomes a big issue, because those spacings that I had found is that not fully being utilized to advantage. There are exceptions to every rules, and some of the rules are some of the spacing exceptions in understanding those. If you go and look at the state rules, which we have for the field rules in our exercise, we come back and it tells us what our lease spacing is, and then the number of acres and well spacing in here. And then it has, you know, the special rules that's not even talking about the side lap spacing, but the hill to toe type spacing. And a lot of people will not get that. They won't quite understand, you know, what did you mean by the hill and toe to the side spacing. I show you in the graphic, you'll notice where I have you look at the illustration. So we're looking at the hill and toe again. This is the hill, this is the toe, and a horizontal aspect of things. You know, some states call this the box rule. You'll see the box considered, you know, what is your side spacing that you have here for your lateral offsets, for the perpendicular offsets that you need to have, and then what is your hill and toe spacing. In some cases you'll see your hill and toe be 100 feet at the ends, but your sides might be 300 or 600 or a different number. Okay, so you might have a different number that you have here for your spacing for your hill and toe aspect of things. And I think in our example, and I'll pull it back over here, I think 330 is what we're looking at here. So you have the spacing between the horizontal wells of the 330 spacing, okay, that you have from the lease spacing over. But on the hill and toe, you also have 330, okay, so it's not the 100 aspect of things. So good luck with this module working on regulatory. I focus mainly on the spacing elements of the documentation. You can use GIS to make a lot of other things that are necessary for the environmental pipeline, things of that nature. I think that the key thing is to build a GIS element that shares data consistently, and you don't reproduce it multiple levels at multiple workflows through the process in the petroleum industry. So good luck.